The Leave Plan of Room specialists has found that using our new 101 billion toy, it will apparently always be before that try changes into a reality. On the remote possibility that it goes as arranged, the excursion to Proxima B will expect near 20 years. So, sensibly, it will be a 2 or 3 years earlier before we can interest expecting there is certain life on that planet. The deepest established question of whether we are really alone in this universe perseveres. Through the James Webb Telescope, we have discovered some incredibly humanesque things far away from Earth that lead us nearer to the answer. Our main goal for life beyond us has been uncontrolled all through human history, to such an extent that we have a critical number of media works and theories concerning this matter. Our wonder about our place and hopelessness in the universe has been predictable. It has permeated inside us to reliably search for a mate, notwithstanding how partial or unlikely we might be. We might get progressively nearer to the answers we really need. However, are they truly the answers we are looking for? Or are they just really upsetting? Join us as we examine the most recent revelations in the space of systems and planets on the excursion to track down something we most likely won't be prepared to see. Lights far away have informed authorities and found what could be the most significant revelation in history. Back in 2021, when the James Webb Space Telescope was planned to launch, an extremely fascinating hypothetical question was raised about the capacities of our technology. The question was whether, later on, our telescopes could detect artificial light on another planet, such as Proxima B, the nearest exoplanet to Earth. Proxima B, around 4.25 light-years away, was determined to be tidally locked with a very long-lasting day-side and night-side, much like our Moon. A hypothetical enhancement for Proxima B could involve moving power and energy from the day side to the night side using photovoltaic cells that make power from starlight. In a paper with Manusvi Lingam as one of the researchers, it was shown that an epic clustering of solar panels on the day side could be detectable with future telescopes. Since the James Webb Space Telescope JWST was further developed, it would allow us to expand our search for artificial lights on exoplanets like Proxima B. Now, the fact that the James Webb Space Telescope did precisely that in 2024, using its higher sensitivity and greater capabilities, is groundbreaking. The JWST might have tracked down the lights we were searching for and possibly flung us into another significant surge of human activity. Overall, we should dive into the universe of planets and exoplanets to figure out how this was even possible. James Webb's mission explores Proxima B and its secrets. From the beginning of recorded history, individuals have contemplated the possibility of the universe, what we are, where we come from, and where we are going. These are natural yet strikingly problematic questions that humankind has tried to answer since gaining self-awareness. In this era of extraordinary technological advancement, one wonders whether we are any closer to answering these questions. If you were to ask a philosopher, he might say we are still at level 0 of understanding ourselves and the universe. However, ask a space expert the same question and watch him eagerly share the latest discoveries about the universe using advanced tools. These tools, though not often considered by the general public, are a testament to human progress. Today, we have the world at our fingertips, and it is time we push further to grasp the universe as well. One such effort by specialists and astronomers is the use of technology to detect artificial light on planets light years away. Indeed, we are discussing the James Webb Space Telescope. This remarkable creation is the result of human endeavors to answer ever-present questions. Are we alone? Who is out there? Where do we start? And where do we end? This infrared astronomy device has already begun observing these questions. If you are wondering what Proxima B is, Proxima Centauri B, or simply Proxima B, is sometimes referred to as Alpha Centauri CB. It is a super-Earth exoplanet that orbits an M-type star. Super-Earths might confuse you, but do not worry. This explanation will clarify all your questions. Super-Earths are a class of planets more massive than Earth, but lighter than ice giants like Neptune and Uranus. They are unique. They can be made of gas, rock, or a combination of both, and their sizes can range from twice the size of Earth to several times its mass. Proxima B is both a super-Earth and an exoplanet, meaning it orbits a star outside our solar system. The first possible evidence of an exoplanet was discovered as early as 1917, though it generated little interest. Confirmation came in 1992 with the first verified discovery, which left researchers astonished. Another exoplanet, first detected in 1988, was confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems. Of these, 896 systems have more than one planet. Proxima B orbits an M-type star. To understand M-type stars, you need to understand red dwarfs. A red dwarf is the smallest type of star in the main sequence. Red dwarfs are the most common type of star found in the Milky Way. They have low luminosity, which makes them difficult to observe. These stars are named based on their temperature and size, with M dwarfs emitting a maximum temperature of around 3,000 K. Proxima B's mass is known to be 1.07 times that of Earth. Interestingly, it takes only 11.2 days to complete one orbit of its star compared to Earth's 365.25 days. This rapid orbit reflects the small size of its host star. Proxima B receives just 1.6% of the Sun's luminosity. Back in 2016, Proxima B's discovery was announced. You might ask why Proxima B holds so much significance. Its proximity to Earth, coupled with its potential to host conditions suitable for life, makes it a prime candidate for exploration and research. Despite its dim host star and relatively low energy levels, Proxima B resides within the habitable zone, where liquid water might exist, a crucial ingredient for life as we understand it. The intriguing properties of Proxima B, combined with advancements in technology like the James Webb Space Telescope, JWST, have opened a new frontier in our quest for understanding the universe. The JWST's ability to detect minute variations in light and analyze the atmospheres of distant planets has revolutionized how we search for extraterrestrial life. In 2024, using its unprecedented sensitivity, the JWST observed Proxima B with a precision never before possible. By studying the planet's light spectrum, scientists have sought signs of artificial illumination, potential evidence of advanced civilizations harnessing energy on the planet's surface. This capability represents a groundbreaking step forward in exoplanet exploration. The study of Proxima B also brings attention to its host star, Proxima Centauri, a red dwarf with characteristics vastly different from our Sun. While red dwarfs are abundant and long-lived, their frequent solar flares and strong stellar winds pose challenges for habitability. However, Proxima B's tidally locked nature, with one side perpetually facing its star and the other shrouded in darkness, raises intriguing possibilities for climate and energy distribution. If Proxima B indeed supports life, it would answer humanity's most profound question: are we alone? But as we edge closer to potential answers, we are faced with an equally daunting question. Are we ready for the implications of such discoveries? The realization that intelligent life exists beyond Earth would fundamentally reshape our understanding of our place in the cosmos. This is where science fiction meets science fact. For decades, stories of extraterrestrial encounters have captured our imagination, reflecting our hopes, fears, and curiosity. Today, the tools at our disposal, like the JWST, are turning speculation into data, providing insights that were once confined to the realm of imagination. But this journey is not without challenges. The sheer distance of Proxima B, 4.25 light-years away, makes it an unreachable destination with current technology. Even at the speed of light, messages to and from the planet would take over 8 years. Developing faster methods of communication and travel is crucial for turning Proxima B into more than just an object of study. As we continue to explore the universe, Proxima B remains a symbol of humanity's unyielding curiosity. It reminds us that while we may not yet have all the answers, the journey to find them is just as important. Proxima B challenges us to look beyond our own world, to dream bigger, and to push the boundaries of what we believe is possible. So, as we peer through the lenses of telescopes and decipher the faint whispers of distant stars, we are not only seeking new worlds but also redefining our understanding of existence itself. Whether Proxima B harbors life or not, its discovery marks a milestone in our collective journey, one that will inspire generations to come. With 1 million stars, planets, and universes, it is of such magnitude. Concentrate well. There are several reasons that add to the observable interest cosmologists have here. Specifically, Proxima B is the nearest known star to our Sun, and by definition, albeit 4.2 light-years away, it holds a significant place for us Earthlings. In the stupendous plan of the universe, it is a straightforward blip. Consequently, Proxima B, our closest realized star, is high on the priority list right now. It is part of the triple-star framework called Alpha Centauri. Despite Proxima's radiance being incredibly low, the framework itself appears as one of the brightest celestial bodies in the night sky, just behind Sirius and Canopus. Anyway, the most enchanting thing about Proxima Centauri B is that it could truly be habitable, as it falls within the habitable zone. The potential possibilities surrounding this star are endless. Consequently, cosmologists have taken on the task of exploring the depths and limits of the star's true potential. That is where the James Webb Space Telescope, JWST, comes in. The four primary objectives of the JWST are 1. Search for light from the first stars and galaxies that formed in the universe after the Big Bang. 2. Study the universe's development and evolution. 3. Understand star and planet formation. And 4. Focus on planetary systems and the origins of life. As the JWST continues its assessment of the said exoplanet, we draw closer to the pinnacle of these missions. From searching for exoplanets to looking for extraterrestrial life, what exactly is at stake? One might ask. Considering that humanity has always been a curious species, exploring and delving into everything that moves and doesn't move, it makes sense that a mission like SETI, Search for Extraterrestrial Intelligence, emerged on such a large scale. Imagine that the universe is a grand, colossal undertaking, written with a hint of gold. We are tasked with keeping an eye out for signals, more specifically, electromagnetic murmurs from other civilizations, beyond what we could ever imagine. SETI resembles the world's most high-stakes game of hide-and-seek, with us as the searchers and the vast universe as the seemingly infinite hiding place. It is one of those fields where scientists act like advanced Sherlocks, tuning into radio waves and scouring for that subtle "we are not alone" signal. This astronomical search began in the 1960s. Frank Drake, a notable astrophysicist, was among the first to recognize radio transmissions from the stars. It was a significant moment. However, no aliens appeared at his door then. As you might guess, searching for something this colossal requires patience and can span decades. Although few definitive alien signals have been found despite these efforts, the excitement persists. As the James Webb Space Telescope continues to examine exoplanets like Proxima B, a new field of hope is emerging. Will we stumble upon genuine proof of extraterrestrial life? Or will we merely encounter cryptic signals just beyond our ability to comprehend, leaving us with more questions than answers? The discovery of light, actual evidence of life, could mark the next chapter in humanity's eternal quest, where curiosity and progress blur into one grand, exhilarating space story. So let us keep searching, hoping to find confirmation that we are not alone. The discovery of lights from distant exoplanets like those potentially seen on Proxima B could be a bold step toward answering one of humanity's most profound questions. Are we alone in the universe? As the James Webb Space Telescope continues to analyze the skies, its discoveries will undoubtedly spark more discussions, investigations, and perhaps challenges to our fundamental understanding of life, intelligence, and the nature of the universe. The implications of these discoveries extend far beyond mere curiosity. They carry the potential to reshape our philosophical and scientific frameworks. For instance, if we were to confirm that Proxima B or another exoplanet harbors some form of life, it would compel us to reconsider our position in the universe. Could life elsewhere develop in ways similar to our own? Or would it present a completely new type of existence? Would it follow the same evolutionary paths? Or would its biology and consciousness challenge everything we know about life on Earth? Even if we fail to find direct evidence of intelligent life, the mere fact that we could detect artificial signals or lights from distant universes would still have profound implications. It would mean that intelligent civilizations exist out there, at least hypothetically, capable of adapting their environments in ways detectable from our vantage point. This would confirm that intelligent life is not an anomaly, but perhaps a widespread outcome of specific conditions in the universe. However, it is essential to remain grounded and cautious in the face of such discoveries. While the potential for finding life is exciting, it also raises the question, what happens next? How would we respond to the confirmation of extraterrestrial life? Would we approach it with respect, curiosity, and scientific rigor? Or would the discoveries spark panic, fear, or even political conflicts? History has shown that humanity's responses to new revelations, especially those that challenge deeply held beliefs, can be unpredictable. We should also consider the ethical aspects of our curiosity. If we do find evidence of life, particularly intelligent life, what does it mean for our responsibility as stewards of our planet? What moral considerations should guide our interactions with other forms of life, whether microbial or advanced? These are not questions that can be easily answered, and they will likely become a central part of the discussion as we venture further into the universe. Nevertheless, the search for life beyond Earth, led by instruments like the James Webb Space Telescope, represents an exciting intersection of science, philosophy, and humanity's future. The next few years will likely be filled with more discoveries, more questions, and perhaps even answers that challenge everything we thought we knew about the universe and our place within it. The story of our search for extraterrestrial life is only beginning. With each new development, we move closer to a moment that could change the course of humanity's history forever. The implications of discovering life, whether microbial or intelligent, would ripple across multiple domains: scientific, philosophical, and societal. For scientists, the presence of life elsewhere would present an unprecedented opportunity to study biology beyond Earth, unlocking answers to questions we've only speculated about. What biochemical pathways might extraterrestrial life employ? Could they utilize elements or compounds unfamiliar to Earth-based organisms? These inquiries could redefine our understanding of life's diversity and adaptability. Philosophically, such a discovery would compel humanity to confront fundamental questions about our existence. If life is a common phenomenon in the universe, what does that mean for our sense of uniqueness and purpose? Would it diminish or enhance our place in the cosmos? Religions, ideologies, and cultures worldwide would likely respond with a mix of introspection and reformation, adapting their narratives to incorporate this expanded understanding of life's potential. From a societal perspective, the discovery of extraterrestrial life could either unite or divide humanity. On one hand, the recognition of shared existence in the universe might foster global collaboration, encouraging nations to work together to explore and understand this profound revelation. On the other hand, fears of the unknown or competition for access to newfound knowledge and resources could spark conflicts or heighten existing tensions. The role of technology. The role of advanced technology, such as the James Webb Space Telescope, cannot be overstated in this quest. Equipped with unprecedented sensitivity, it allows astronomers to analyze the atmospheres of distant exoplanets for potential biosignatures. Molecules like oxygen, methane, and water vapor, if detected, could indicate the presence of life-supporting conditions. In parallel, initiatives like SETI continue to monitor radio frequencies for artificial signals, hoping to intercept communication from intelligent civilizations. These efforts, combined with emerging technologies like artificial intelligence, are increasing the likelihood of identifying patterns or anomalies in vast data sets. However, as our tools improve, so does our responsibility. Detecting life is only the first step. Humanity must carefully consider how we approach and communicate with any potential extraterrestrial intelligence. Should we attempt to send messages, Or would that risk exposing our location to unknown entities? These questions underscore the need for a cautious and deliberate strategy in our exploration of the cosmos. Preparing for the unknown. The discovery of extraterrestrial life, whether intelligent or not, would demand careful planning and consideration. International protocols, such as those established by the United Nations Committee on the Peaceful Uses of Outer Space, might need to be expanded to address ethical and practical concerns related to interstellar communication and exploration. At the same time, we must prepare for the possibility that life elsewhere might differ so drastically from our expectations that it challenges our ability to recognize or understand it. What if extraterrestrial life is based on entirely different chemistry, or exists in dimensions or forms beyond our current comprehension? Such scenarios emphasize the need for open-mindedness and adaptability in our scientific approaches. A future defined by discovery. As humanity stands on the brink of potentially epic-making discoveries, one thing is clear. The search for extraterrestrial life is not just about answering a scientific question. It is about understanding our place in the cosmos. Whether we find microbial life on a distant exoplanet or receive a signal from an intelligent civilization, the implications will shape the trajectory of human history. The next steps will require courage, collaboration, and a commitment to scientific rigor. The universe, vast and mysterious, continues to invite us to explore its secrets. With each new discovery, we are reminded of our capacity for wonder and our insatiable curiosity, a defining trait of humanity that drives us to look beyond our horizons, seeking not just answers, but meaning. So, as the James Webb Space Telescope and other groundbreaking instruments probe the depths of space, let us remain hopeful and vigilant. The universe's story is one of endless possibilities, and we are privileged to be part of its unfolding. With every question answered, 1,000 more will arise, propelling us further into the great unknown. The journey has only just begun.